So my name is Lorraine Hanlon and I'm the academic lead for EIRSAT-1, and that means that I look after all the students who are working on the project, who are building the satellite.
My name is Lana Salmon and I am outreach manager for EIRSAT-1. That basically means that I need to kind of get the story out there, get students involved and spread the story, but I'm also in charge of the ground segment, which is basically what's on the ground when EIRSAT's in the sky. So it's kind of like mission control, if you want to call it that.
My name is David Murphy. I'm a PhD student in the Space Science group, and as part of that I'm the systems engineer for EIRSAT-1.
So I'm Joe Flanagan and I'm working on the EMOD payload. So it's the secondary payload for EIRSAT-1, and EMOD stands for the Bio Module. And I'm the lead engineer, I suppose, for EMOD.
My name is Willie O'Connor. I'm an associate professor in UCD, School of Mechanical and Materials Engineering. So my involvement in EIRSAT came in somewhat later, and I'm looking in particular at what's called attitude control.
So EIRSAT-1 is Ireland's first satellite. It stands for the Educational Irish Research Satellite. And the main goal of it, I think, is to be educational. That's why the E is there. So it's a bunch of students in University College Dublin, and we're basically learning as we go, trying to build a little satellite. It's about this big, and we don't have expertise in this area. So the point behind this satellite is that we're learning how to build a satellite so that generations to come can also kind of build on that, and we'll end up building bigger missions and also have the students, I suppose, the expertise in Ireland, so that we can build the Irish space industry even larger and be a part of the space generation.
There probably is no such thing as a typical day, and there's a lot of jobs and roles that I do. So as well as sort of talking to all of the people who are in charge of the various subsystems and dealing with them, making sure that their ideas and their input is compatible with ESA's requirements. I'm also in charge of the GMOD module, so I spend a lot of time in the lab testing components for that as well.
Essentially, the main challenge is trying to coordinate all our work to the schedule that the European Space Agency want us to keep, and also to figure out what funding we need, where we can get the funding, and also what the legal challenges will be and how we can solve those. So how do we actually overcome the fact that we have no Irish space law?
So in 2014 I finished my Bachelor's of Engineering here in UCD, and I actually was intending to emigrate to Australia, but I contacted one of my lecturers, Ken Stanton, who had mentioned in passing that he might be able to get me an internship for the summer. So I decided I'd get the internship before heading away and get some experience. And I've been studying and working with Bio for the past 3.5 years now on my PhD, and hope to submit in September. And through Bio, I've been working with EIRSAT-1 and got involved in this project as well.
So for me, the best thing about this project is working with these incredible students who are unbelievably talented and should give everybody hope for the future, because it's in very safe hands with these amazing students.
So first of all, I love all of the job, but probably the worst part of the job is the documentation. We spent the entire summer writing documentation. We wrote almost 500 pages for the European Space Agency. That was a slog, but we got through it, and we're getting through it. Yeah, that's probably the worst part.
I think that, well, when I was an undergrad studying astronomy and space science, we learned a lot of problem-solving skills. I think you need an analytical kind of mind. You need to be able to take apart things. You know, you've got this big satellite, well, it's that size, but you've got loads of stuff in it. And you need to be able to figure out how each bit, works. So you definitely need to be able to kind of have that mindset as well. So I think they're the kind of skills that I bring to it, yeah.
Probably the two biggest ones would be applied maths and physics. They're my favourite subjects in secondary school. From a young age I kind of knew I wanted to be a mechanical engineer, So my subject choice was guided towards that in that way, but they're my favourite subjects through secondary school, and I think they definitely helped focus me towards where I am today and what I'm doing today.
Well, the first thing is find out whatever you can, because your interest grows the more you know about something, and you'll quickly find out, am I interested in this or not? And so typically the more you know about something, your interest grows. And my experience is people who are interested are generally good at it. So they go together, and so your interest motivates you to find out more, and then as you find out more, you get more interested. So it's a virtuous circle, and and then the science subjects, physics, chemistry, certainly are very helpful. So yeah.
So I think passion is definitely one of them. You need to really love what you're doing. If you love what you're doing, I think you'll do really, really well. And that was kind of one of my stories, I suppose, is that when I did my leaving cert, my maths and physics were my worst subjects. And I loved doing that anyway. I didn't mind spending the time on it. So I think you need passion and dedication to kind of, work hard, keep going. And an analytical mind. I think they're the three: passion, dedication, and analytical mind. Yeah. Maybe going into a university lab and experiencing research would be great. So I know here in UCD we have students who come in and they sit in with us and they see what researchers do, because a lot of this project is just researching. It is asking questions and finding the answers. That's why we have our 2 experiments. They're being flown because they're new and we don't know what exactly they're going to do yet. So that's what a researcher does. So try and get in with a university lab with researchers. That would be definitely a good work experience. Or an engineering department if you want to start building things. Tech companies would be good too, because they solve problems all the time. That's their job. So yeah, definitely. Those would be the best kind of work experience that people could get. Yeah.